Okay, problem 315 asks us to calculate the cell edge length for a cell of iron oxide, FeO. FeO has a rock salt crystal structure and also a ratio of 1:1 of the iron and the oxygen. So we're going to use equation 3.6. Equation 3.6 is the density for a ceramic. The density for the ceramic asks us to calculate the mass for a unit cell on top and the volume of that unit cell on the bottom. N prime is the number of formula units per cell, and we need to have the atomic masses of each cell component. So in this case it would be Fe and O. Notice that there's only one of each in this situation. And divide that by the volume of the cell times Avogadro's number. Well, for this problem, we need the cell edge length. That can be found by calculating for the volume of the cell. The volume of the cell is the cell edge length cubed. It's a cube. We have Avogadro's number as a given. We can look up the atomic mass of iron and the atomic mass of oxygen. We know that based on the rock salt structure, there are 4 unit cells, or formula units, excuse me, per unit cell, and we're also given a density of 5.7 grams per cubic centimeter. So we have everything. All we need to do is solve for A cubed. So rearranging the equation, Vc equals N prime AFE plus the atomic mass of the oxygen all over the density times Avogadro's number. Plugging our units in, we have 4 formula units per cell times the atomic mass of iron. Atomic mass of iron is 55.85 grams per mole, and the atomic mass of oxygen is 16.00 grams per mole. Divide by 5.70 grams per cubic centimeter times Avogadro's number. Now, calculating all this out, first off we'll cancel out the units. Grams are gone, formula units are gone, moles are gone, and we end up with 8.375 times 10 to the -23rd cubic centimeters per cell. Again, this is equal to a cubed, so if we take the cube root of that and we translate it into nanometers, we end up with 0.438 nanometers. Now, Fe and O each have radius, if you will. So if we have Fe here and the oxygen here along this cell, this should be approximately our edge length. So 2 times the radius of iron plus 2 times the radius of oxygen. Now that's O negative and 2 negative and Fe2 positive. We have 2 times 0.077 nanometers plus 2 times 0.140 nanometers. We end up with 4.434 nanometers, which is actually quite consistent with that calculation.